Okay, give me some properties of metals.
High luster. Thought we already did this.
Okay, luster.
Yeah.
It's showing up on the assessment Friday. Luster.
Shiny, high density.
High density conductors.
Mostly solid.
Solids.
Malleable. Ductile.
Ductile, malleable. What else?
Lose electrons.
We'll get into ions in a second. But you're right. Anything else? Typically, they have high melting points, too. So you might want to put that in there. Typically, they have high melting points. You know, you think of, well, lead's fairly low, but, you know, gold, silver, aluminum, copper, they don't melt at low temperatures. They have fairly high melting points. Metals, in general, when you talk about characteristics, metals have high melting points as a general characteristic. And they lose electrons to form cations, or a positive ion. Well, when you think about nonmetals then, that's really what? Just the opposite. Of the two categories on the periodic table, which one has the greatest abundance? Yeah, definitely the metals. You know, anything to the left of that staircase are metallics. Anything to the right are the non-metallics. All right. So make sure you know the characteristics between metals and nonmetals. And I'm not going to write them all out. You guys are pretty good with them. Okay, so we said metals lose electrons and become cations. Nonmetals gain electrons and become anions. So you have that going on also. And what type of bond is this? Covered that Friday with the Tootsie Pops. That is an ionic bond. Ionic bonds are polar. Ionic bonds are polar. Those are referred to as polar bonds. In other words, they got an area that has a positive charge and an area that has a negative charge. When you think of sodium chloride, you've got the positive charge there and the negative charge there. That is referred to as an ionic bond. And they are polar. Ionic bonds are polar. And ionic bonds are between metals and nonmetals. Right. And the metal, yeah.
That's Cl, not C1, right?
Cl, yeah, sodium chloride. And they form that whole idea of an ionic bond, and they are polar. The other thing to remember, like dissolves like. Like dissolves like. Polar compounds are dissolved by polar solvents. And what's one of the best polar solvents out there? Water. Water is the universal solvent. Water is the universal solvent. Water is highly polar. Let's see, get this out of this one. Water is a highly polar compound. It's got a pretty strong negative side to it and a pretty strong positive side. So that's considered a polar compound. So like dissolves like. All right. Questions on this? I think most of that is review. All right, let's look at ionic compounds. Just let A be any metal, and let B be any nonmetal. Metals are always written first. Metals are always written first. That's a horrible let, isn't it? Leb. What you need?
I need a
Meter stick. I think we can do that.
Thank you.
Well, let's see. Let's do X. Let X be a positive charge. Let Y be negative charge. All compounds got to be electrically what? Neutral. In other words, you got to have the same number of positive charges as you have negative charges. An easy way to do this is that old idea of crossing. So we got a metal, sodium, magnesium, gold, copper, whatever you want. And all these have a certain charge to them. You know everything in the alkali metals has a charge of what? First column. 1. Everything in the alkali earth metals have a charge of positive 2. And then you have your ionic charge table for all the other ones. I don't expect you to memorize those. I have that table in front of you. And as we keep going over stuff, you're going to start internalizing them quite a bit. Negative charges have what type of charge? Negative, I guess, and they are the non-metals, right? Everything in that column with chlorine is called the halogens. And what's the charge on all those? -1. And if you move to the left, the oxygen family has charges of -, and then I believe the next one's the nitrogen family has charge of -3. And there are others that you can look on that table I gave you the other day. Well, to get a neutral compound, so when you write the symbol, A and B could stand for any metal, non-metal. X and Y are the charges. Yeah, I guess we could put a plus here and a minus there. Cross the charges. Just bring the number. Do not bring the sign. And that is a subscript. You just cross them. Number only, not the sign. Number only, not the sign. Just bring the number, and it is a subscript for that particular element. Again, metal, non-metal, positive charge. Take the number, becomes a subscript for the non-metal. This becomes a subscript for the metal. Yeah?
What if there was like ABC?
We're going to look at those probably tomorrow. But the only time you see like an ABC, the BC would be what's called the polyatomic ion. Good question, though. And we'll look at those hopefully tomorrow. All done?
Yeah, thank you.
You bet. There was that I call it the S curve on Pine Island up there by Post. People just screamed through that. There was a county cop sitting there, and there was a van he's about 40 feet into the swamp there on the west side, only about 20 feet from the telephone pole. Probably wouldn't have been good there. Yeah, this morning. Yeah. A's got a charge of 3, and again, I'm not going to say positive 3 if it's positive. And then B's got a charge of a -4. What is the formula? A4, B3. No, do not bring the sign with it.
No, like I mean, at E, like to the stage, you just ignore it.
When you're doing number-wise, and the reason this works, you know this is 3, this is 4 minus. 4 times 3 is 12. 3 times a negative 4 is a negative 12. Add them together, and you get 0. Yeah, do not bring the signs with you. Just bring the number as a subscript.
Why do you just leave them at the top?
Because that's charges. That is not the number. So this is saying I got 4 A's and how many B's? 3. And they're saying each A has a charge of 3 and each B has a charge of negative 4. And that's why you have to do it that way. That rule holds true for everything on that ion chart I gave you. If you pull that ion chart out, you can do that for any compound. So that's a good little trick to remember. The old cross. Just cross the numbers, don't bring the sign down. You can't go wrong. But I've seen it go wrong, but you can't go wrong. So tomorrow, what I'd like to go over tomorrow is the one you picked up on Friday. So I like to do that first thing, and then we're going to get into some polyatomic ions. Any questions? A little bit of review. All right.